Now that you've tried the got it problem on the previous page to check your understanding, let's move on and look at how we can compare variations. So we can compare mean absolute deviations for two data sets. A data set with a smaller mean absolute deviation has data values that are closer to the mean, or closer together, than a data set that has a greater mean absolute deviation. So basically, if the mean absolute deviation is greater, that means that those data values are more spread out and further away from the mean. Let's look at example 2, and I apologize I had to fit it all on the screen, so it's a little small, but you can look in your book there. Example 2 says the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in millions of dollars and are rounded to the nearest hundredth. So they give the top 5 salaries and the bottom 5 salaries. They want us to find the mean absolute deviation for each set of data, round to the nearest hundredth. So to find the mean absolute deviation for the top 5 salaries, you find the mean, which they found is 23.40, and then from there you can find the distance that each data point is from that 23.4 and find the average of that to get your mean absolute deviation of 4.19. So the mean absolute deviation is about $4.19 million. Then I'm going to find the mean absolute deviation for the bottom 5 salaries. So to do that, you first find the mean, which they have here as 0.43 or $0.43 million. And then I'm going to find the distance that each data point is from that mean. And I'd find the distance and add them up, divide by however many there are, and find the mean absolute deviation of 0.01. So the mean absolute deviation is about $0.01 million. So obviously the bottom 5 salaries here have a smaller mean absolute deviation, okay, if I compare these two values. Okay. And part B here writes a few sentences comparing these variations. It says the mean absolute deviation for the bottom 5 salaries is much less than that for the top 5 salaries. The data for the bottom 5 salaries are closer together than the data for the top 5 salaries. So because the data for the bottom 5 salaries, it has such a small mean absolute deviation, I know that all those data points are much closer together than something that has a larger mean absolute deviation, meaning that the data is going to be more spread out. So when you write a few sentences to compare variations, you basically want to write 2 sentences. One that tells which of the two is greater or less, and then another that gives me an identification of, what those mean absolute deviation means. The fact that the smaller mean absolute deviation means that the data is closer together, or the fact that the larger mean absolute deviation means that the data is more spread apart or has more of a variety to it. Try the got it problem on the next page to check your understanding.